In this video, we're going to be learning a strategy to help us to name different oxyacids that all share not identical but similar polyatomic ions within their structure. For example, if we take a look at the second polyatomic ion here, we see that if we remove the hydrogen, the chemical formula for that polyatomic ion is ClO3-, which goes by the name chlorate, and we can treat this as the starting point or as the default for naming the rest of the oxyacids that we see here. So chlorate is the acid that contains a polyatomic ion that only ends in ATE, and we can write the name chlorate here just to be safe, and this acid here follows all of the regular naming rules in that all we need to do is replace the ATE with the suffix ic acid exactly as we might suspect. So this acid would be called chloric acid here. Now if we go to this acid here, we can see that the polyatomic ion has one fewer oxygen here and goes by the chemical formula ClO2- instead, and therefore this polyatomic ion, ClO2-, would actually go by the name chlorite here, and that likewise forms the basis of our naming system because the polyatomic ion suffix is ITE, and therefore it won't be an ic acid but would actually be an us acid or an OUS acid instead. So this acid would be called chlorus acid. And again, so far what we've done here is exactly what one might expect when following the traditional naming rules. All that we want to see are the patterns that occur as we remove oxygens and as we add oxygen. So if we go to the final polyatomic ion on the right, if we remove the hydrogen, we can see that the polyatomic ion will be ClO-. So if we look at the second step here, chlorite, we can see that this polyatomic ion has one fewer oxygen than chlorus acid, and the polyatomic ion for this, rather than being chlorite, would be called hypochlorite. And the shortcut that we can use for the name here, and either way we can see that this works, this polyatomic ion ends in ITE, so we would therefore replace the suffix with OUS acid, and therefore this acid here would be called hypochlorous acid, and we can see the shortcut to go directly from this acid based on chlorite to this acid based on hypochlorite here is just to add the prefix hypo to both the polyatomic ion and the acid that we see here. In fact, this prefix here, hypo, is a prefix that actually means less than. For example, if you are dying of extreme cold, you would be suffering a condition called hypothermia, which means less than the amount of heat that you need in order to survive. So in this case, the hypochlorous implies that we have one fewer oxygen than the previous acid, which is chlorous acid that we see here. So this hypo is a little bit of a tip-off that we removed oxygens in order to get to this point. But what about if we wanted to add oxygens here? So if we start with chloric acid, and if we go to this polyatomic ion here, we will see that it has the chemical formula ClO4-, meaning that we have actually added an oxygen in order to get to this point. So if our polyatomic ion actually has one more oxygen atom than the starting point, than chloric acid, we can add the prefix per in order to indicate that we have added an oxygen. For example, this polyatomic ion, ClO4-, actually goes by perchlorate to show that it has one more oxygen than chlorate. In fact, the word per actually means to add, and in this case, it's referring to the oxygen. And if we follow the traditional naming rules, the ATE, let's just write out our polyatomic ion name again, the ATE we would remove and we would replace with ic acid, and so it still follows the traditional naming rules, but we can use the reference to the prefix per to indicate that we have added an oxygen from the original form like this. Now, technically, this per, ic, us, hypo, us pattern actually applies to many different acids that we see here, including some of those that don't actually exist on your data table. So to practice the naming rules, see if you can start with the default form of a polyatomic ion, that being this one, iodate here, and see if you can use the per, ite, and us suffixes and prefixes to identify the closely related polyatomic ions, identify the chemical formulas of the acid they form, and name the acid using the traditional rules and this little pattern that we see to see whether your grasp of oxyacid nomenclature is as strong as it needs to be.